Hi everyone, this is Akyam Yagantishwarudu. Welcome back to our machine learning sessions. In the previous session, we are discussing about machine learning phases, machine learning life cycle. We discussed about data extraction, data cleansing, and analyzing the data. In today's session, we'll continue with the remaining phases. And if anyone missed about previous phases, just go and watch our previous session. You can get a clarity on data extraction, data cleansing, and analyzing the data. We'll continue with the remaining phases. So data preparation for models. So what is data preparation for models means one will be dividing the training and testing set, and maybe normalizing the data set, convert the categorical data. So here I will give the brief definition of this, but in depth we'll discuss about in separate sessions. So training and test set and normalizing the data set, or we can convert categorical data. There will be multiple other steps are there in data preparation. These are the major things we can follow. Training and test set, I will take a separate session. There will be different approaches are there which are useful, which are having if I use those approaches, what are the benefits and disadvantages? I will take a separate session. Usually training and test set, what we can do is, as per industry standards, we are going to follow 70-30 approach. Means if I have 1,000 records for diabetes, let us assume diabetes data set prediction we are doing. I can use 700 records for training and 300 records for testing. So why I need a training records, why I need testing records, I will take a separate session. We'll discuss there about why I need training and testing records. Usually in industry, we will follow 70-30. Sometimes we can follow 80-20 also. Let us assume 800 records for training and 200 records for testing. Something like this. So this is training and test set, dividing the data into training and test set. And so dividing the categorical data means, for example, our machine learning models will understand only categorical features, numerical values. So our machine learning model, so which will usually understands numerical values. So for example, if I take a symptom, or let us say convert categorical data, like for example, symptom presence or not, there is some uh, data set, let us say COVID-19 data set only, COVID-19 data set. Let us say there is one column called as gender. So gender will be something like male, female. So in a given data set, something like male, female, male, and so on. So like this, the patient details are there. But as I told, my machine learning model will understand only numerical values. If this is in the text format, it will not able to understand. In that case, I need to convert this into the categorical data. So for example, male means 1 and female means 0, something like this. I can convert like this, 1, 0, 1, something like this. So there will be multiple techniques while converting categorical data, how to convert this categorical data. We can discuss what are the different algorithms available to convert that into different categorical values, because our machine learning will understand only numerical values. This is one example of data set preparation. So training and testing set and converting categorical values, sometimes normalized values. For example, if you remember when I'm discussing bank loan application, salary of the employee is one of the criteria. So where some persons having 10, 15, 20K, 10, 15, 20K, and so on. Like this, most of the persons 10, 15, 20, 25, 15, 10, and so on. But very few records, let us say out of 1,000 records, 5, 10 records having 1 lakh, 1 lakh, 1.5 lakh, and so on. If you see, 10,000 is very far to 1 lakh. 10,000 is very far to 1 lakh and 1.5 lakh. Means there is a huge difference between the salary of 10K and 1 lakh. If I try to cluster this, there will be the clustering will not happen properly. So what I need to do is I need to normalize this data, normalize the data. So there will be different normalization techniques like min-max normalization, standard normalization. There will be different techniques are there. So where I can convert between 0 to 1 so that within this scale, it is easy to fit the data. It is easy to cluster the data where I cannot find the huge differences between the clustering. So that's why when you are converting your data, if you convert your data wherever it is required into normalize the values, then your clustering or your model design will perform output accurately. So which will predict the accurate output. So sometimes this normalization. So these are the tasks which we can perform. Usually we are going to perform in data preparation. As I told, I will take a separate session on training and testing set preparation. Next, model selection. So I'm going to quickly discuss about model selection, training, evaluation, deployment, because all these we are going to discuss in a separate sessions. And model selection and training and evaluation. So maybe I can combine this into a single step or multiple steps also we can combine, because these almost all these three belongs to in one category, that is model related. Model selection, train the model, evaluating the model. So what is model selection means, if you remember when I'm explaining the differences between what are the different types of algorithm, that is supervised, unsupervised. So first I need to find what type of data set is it is, what type of data set, and after finding, so for example, if it is supervised learning, if it is supervised learning, if it is classification, if it is classification, I am having set of models like random forest, random forest, decision tree, decision tree, support vector machine, and so on. I am having multiple algorithms. If it is regression, I am having linear regression, and so on. Multiple regression algorithms are available. Next, if it is unsupervised learning, I'm having different algorithms like k-means, db-scan, and so on. So what you need to do is, first you need to means you need to know what kind of data set it is. Based on that, based on the type of data set, you need to choose the corresponding algorithm. So model selection is nothing but you need to choose the corresponding algorithm. So what is training means, with our given data set, I need to pass my input data to model. So input data to my model. Model is nothing but my machine learning algorithm. And so here this machine learning model, so which will observe all the patterns in the data set. That concept we can call it as a training. So how to train means how the machine learning model will train with those input data set with the clear understanding. For example, if you say a random forest, how it will work and how it will get the training of the given data set, and if it is a decision tree, if it is a SVM, how those going to train with the clear practical explanation we'll see later. Training is nothing but which will take the input data and which will observe all the patterns in the data set so that it is able to predict the future data set. And evaluating the model means after training my model with the data set, I need to evaluate which is performing better accurate model. For example, if I take classification, let us assume diabetes prediction system you are designing. And if I apply random forest, let us assume it is giving 95% accuracy. And if it is support vector machine, let us say it is giving 92% accuracy, and so on. Let us assume you have applied some multiple algorithms. Then choosing the best algorithm is called as evaluating the model. Here we means there will be multiple multiple metrics are there. If it is a classification, we are having accuracy, F1 score, precision, recall. We'll discuss all those definitions with examples in the later sessions. Means what is evaluating the model means we need to choose the best model for final deployment. So if it is working fine, because in the future it has to predict the live data, that is evaluating your model. And finally, deployment and rebuilding the model. Deployment means, for example, I built my model, and if I keep with myself, it is no use for outside world, right? I need to deploy in the server. So for example, if you see Facebook, Gmail, WhatsApp, Twitter, and so on. So those are the social websites. If I develop and keep with myself, nothing will happen. So I have to deploy so that www.facebook.com means everyone is able to access Facebook application and they are able to use that Facebook application or Instagram or WhatsApp. So we need to deploy in the server. Here in the later sessions, what I will show you is after designing my model, I will show you how to consume in the front end. Maybe for CI/CD pipeline, I will show you later. But up to our machine learning sessions, what I will do is I will show you to design some Flask APIs. So Flask APIs are simple to design. So I'm going to explain Flask APIs. But if you know any other APIs also, you can design and you can consume in the front end. I will show you that nature means I will show you simple web application and I will design you ML model and I will show you how to consume in the front end in the later sessions. And this last phase is rebuilding the model is optional. Why I'm saying optional means only if your model is not working, then only you need to rebuild the model. So let us assume you deploy your diabetes prediction and you deployed your diabetes prediction, and after deployment first day, let us say after while building we deployed random forest model, and the first day 95% accurate. As we built also it is means working 95%, that is fine. Second day, let us assume it is reduced to 93. Third day it is reduced to something, let us say 90. And after 1 month, let us assume it is reduced to some 60%. Then client will not satisfy with this accuracy. This concept is called as overfitting. I will take a separate session on this. Overfitting means during training it is performing well and during validation phase after deployment it is not working fine. That concept we will call it as a overfitting. So how to avoid overfitting we'll see in the later sessions. Just remember, means during our development it is working fine, but after deployment it is not working fine. What we need to do, we need to rebuild our model. So we need to model rebuild our model. So we need to rebuild our model so that it may work in future correctly, because the client want exact working model. They don't want which are not working, means which is giving better accuracy. They want that kind of models. That's why we need to rebuild if it is required. But if it is working fine, let us say when I deployed it is working 95%. After 1 year also if it is working 95 or 94. So after 1 year also, if it is working 95% or even 94 also fine. But if it is after 1 year, if it is working only 20% accurate, means that is not acceptable, because we need to rebuild our model by following all those phases. Again, you need to pre-process the data, you need to get more data, you need to train with more data, pre-process, and you need to take care the data, and then you need to feed good data to your model so that it may work fine. So these are the different phases in our machine learning life cycle. So we need to follow at least some of these steps while designing. And I will take one simple use cases. I will show you all those steps, how those steps will work for machine learning. We'll see with an examples. Thanks everyone. We will meet in another session. Please stay tuned for further topics.